Hey everyone, and welcome to our explainer. Today, we're going to crack the code on the secret language of the internet. We're taking all those confusing tech acronyms and turning them into simple ideas you can actually understand and use.
Have you ever felt totally lost in that tech alphabet soup? You hear people throw around terms like IP, DNS, or DHCP, and it just sounds like a completely different language. Well, don't worry, because today we're going to fix that.
So, to make this all super simple, we're going to use one big idea for everything. Just imagine the entire internet is a massive, bustling city. Your computer? That's you. You're a citizen of the city. And every single acronym is just a piece of the city's infrastructure. The roads, the addresses, the phone book, the postal service. Let's get exploring. Okay, so here's our roadmap. First, we'll cover connecting to the world. Then, we'll figure out what your digital identity actually is. After that, we'll learn the languages the web speaks. And finally, we'll put it all together and trace your journey online from start to finish.
All right, let's dive right in. First things first, before you can explore our digital city, you gotta have a way in, right? You need to get connected to the grid.
Let's think of it like this. Your ISP, that's your internet service provider, they're like the city planner, the ones who build all the major highways. Your LAN, that's just the private road or driveway right at your own house. The WAN is that huge global highway system that connects all the buildings together. And Wi-Fi? Well, that's basically just invisible cables letting you wander around your own building without tripping over anything.
So the key difference here is really all about scale. A LAN, or local area network, is tiny. It's small, it's private, it's super fast. Kind of like the quiet streets in your own little neighborhood. But the WAN, the wide area network, well, that's the entire public highway system for the whole planet. It connects everything, sure, but with all that distance and all that traffic, it's naturally going to be a bit slower.
Okay, so you're on the grid, you're connected, but in a city this massive, how does anything actually find you? Simple. You need an address. And that's where your digital identity comes into play. Any device that connects to the internet gets something called an IP address. The easiest way to think about it is like a temporary street address for a hotel room you're staying in. It's how the mail, or in this case, data, finds you. But, and this is key, it's not permanent. The second you check out and connect from somewhere else, you get a brand new one. Now, completely unlike that temporary IP address, your device also has a permanent MAC address. This isn't a temporary hotel address. No, this is more like your passport or the serial number on your phone. It's physically built into the device by the manufacturer, and it never, ever changes. So why on earth do you need both? Well, an IP address is for finding you on the big global highway, the WAN. But a MAC address is for identifying you on your small local network, the LAN. It's how your home router knows which specific device, which person with which passport to deliver a package to inside your own house. So who's in charge of handing out all these temporary IP addresses? I mean, trying to do it manually for billions of devices would be absolute chaos. That's where DHCP comes in. Think of it as an automated clerk at the city's welcome center. The moment you connect, it just hands you an available address. No forms, no waiting, no fuss. And this whole thing happens with a super fast 4-step conversation called DORA. First, your device discovers the network and basically shouts, "Hey, I need an address." The server makes an offer. Your device sends a request back saying, "Yep, I'll take that one." And finally, the server acknowledges it, locking it in. It happens in a split second every single time you connect. But wait a minute. We don't type in long strings of numbers to visit websites, do we? Of course not. We use names, like youtube.com. And we can do that thanks to the magic of DNS, the domain name system. It's literally the internet's giant phone book. You ask for a name, and DNS looks up the actual numerical IP address, the real phone number that your computer needs to make the call. It's the essential translator that makes the web usable for all of us humans. So, we're connected, we've got an address, now it's time to actually communicate. But just like in any real city, you can't just start shouting, you have to speak the right language. And in the world of networking, these languages are called protocols. The most common language on the web is HTTP. And this analogy just says it perfectly. The original HTTP is like sending a postcard. It's wide open, and anyone can read it along the way. That's not great for security. That's why today we almost always use HTTPS. That little s at the end stands for secure, and it's a total game changer. It turns that open postcard into a sealed, encrypted letter that only you and the person you sent it to can ever open. Now, HTTPS is perfect for browsing websites, but what if you're not just sending a letter? What if you need to send a giant shipping container, like a massive video file? For that, you need a totally different service, FTP, the File Transfer Protocol. It's basically the freight division of the Postal Service, built from the ground up for one job, moving big, bulky files as efficiently as possible. Okay, let's talk wireless for a sec. When you open your laptop at a coffee shop, how do you know which network to join? You look for its name in the list, right? Well, that name is the SSID. It's just the public sign on the door. But connecting to public Wi-Fi can be a little risky. If you really want privacy, you use a VPN. A VPN creates your own private, armored tunnel over that public highway. Nobody can peek inside to see where you're going or what you're doing.
We've looked at all the different pieces, the roads, the addresses, the special languages. So now for the really cool part. Let's put it all together and follow one single request from your computer all the way across the internet and back again.
So picture this. You're at that coffee shop. First, you connect to their Wi-Fi by picking its name, the SSID. Instantly, that DHCP clerk gives your laptop a temporary IP address. You type youtube.com into your browser, and the DNS phone book looks up its real number. Then, your browser sends a secure request using HTTPS. That request zips from the coffee shop's local network, the LAN, out onto the global WAN. And in the blink of an eye, the website loads. Every single thing we've talked about, all working together seamlessly just to load one page. It's amazing.
And there you have it. This right here is your official cheat sheet to the city of the internet. You've got the ISP as the city planner, the LAN and WAN as the roads, your IP and MAC addresses as your ID, all the way to the DHCP clerk and the DNS phone book. When you see it like this, it all just fits together.
So, that whole alphabet soup of networking, hopefully it's not so intimidating anymore. It's really just the set of rules that keeps our incredibly busy digital city running smoothly. And so the real question is, now that you speak the language, what are you going to explore or build next? Thanks for watching.